A buffer is a solution whose pH changes very little when small amounts of acid or base are added. Most buffer solutions have about the same amounts of a weak acid and its conjugate base. You have to have both partners to make a buffer. The weak acid of the buffer reacts with any added base or hydroxide ion, and the conjugate base of the buffer reacts with the added hydronium ion, or the acid. So the goal or job of the buffer is to maintain pH. Now, it does not mean that it keeps the pH at a neutral level, like a pH of 7. Instead, each individual buffer will have a varying pH, and that's the pH that the buffer will hold the solution at as long as it's working. You can add so much acid or base to a buffer that you swamp it out and it can no longer control the pH. Our body is composed of several different buffers, so that, for example, we would have blood buffers to maintain the pH level of our blood when different amounts of acid or base are introduced. So below here are 3 pairs which we want to decide, could they be a buffer? So the first one, so we know a buffer has to have a weak acid. Looking back to the common strong acids, I know that HBr is a strong acid. And strong acids cannot be used to make a buffer. So this combination would not be a buffer. Now the second combination, HF and KF. So HF is a weak acid. So we know we have to have a weak acid. And then we want to know its conjugate base. So to figure out a conjugate base, we are going to take away the H+. So taking away H+ from HF, we would just have F negative. Now looking, they put KF. And here's the thing. KF is an ionic compound. Ionic compounds, we've learned previously, dissociate or fall apart. So when I put KF in solution, it would dissociate into K+ and F-. So look here. KF does have our conjugate base. The K is what we call a spectator ion. It will not be involved in the functioning of the buffer, but it's required to be there because I can't purchase F- by itself. So as you're looking at your homework or answering these questions, if you notice that the conjugate base is with a metal, keep in mind that that metal will dissociate and it leaves you with your conjugate base. So HF and KF mixed together would make a buffer. Now the final example was just CH3CHOOH. This is acetic acid alone. So this is a weak acid. But in order to make a buffer and maintain pH, you have to have both the acid and the base. So this one alone could not be a buffer because it has no conjugate base with it. So for this course, I want you to know what buffers are made of and what their job is. We investigated this a little bit more in lab, but for the lecture part, this is what I want you to think about.